everybody. Welcome on a Friday after lunch in a sunny day here in Atlanta to see these two guys writing some YAML. So thank you very much for being here. We really appreciate it. My name is Alberto Ríos, and I'm a software engineer in Pivotal. And I'm here with my colleague.
Yeah, I'm Ollie Hughes. So I'm also a software engineer, was Pivotal, and will soon be VMware for us. So yeah, really happy to be here in Atlanta and to be giving this talk. So hopefully it'll be you could all take away something and learn something. That's our objective for today.
Yeah, so Ollie and I have been working together over the past couple of years on building tools for developers in a platform called Cloud Foundry. And now we switched teams and we are looking into Kubernetes, but from different perspectives. And it's been such a learning curve for us because there are so many things to learn, especially when it comes to developing on K8s, that we just wanted to get together and share different point of views and share with all of you all we have learned. And this is kind of why we decided to get together, right?
Yeah, and it really is, for me anyway, it really was kind of a learning curve to actually be productive, especially coming from something like Docker Compose. Things are quite simple here, but now with Kubernetes, there's more to think about. We spent a lot of time really kind of researching what we feel is the best way of doing things for Java developers. So we want to share with you what we think is a best practice, really. So.
Yeah, exactly. Because you are in a platform as a service, deploying to production is just one CLI command away from you. You're in Cloud Foundry, just do CF push. If you are in Google App Engine standard environments, are very equivalent things, same thing for Heroku. But when you come to Kubernetes, it's a bit daunting, right? You have so many tools, so many things that it can get a little bit overwhelming to trying to learn all of them or just to guess what do they actually do. So this is why I wanted to make this talk in order for us to just let you know which one we found more useful when it comes to developer experience.
And images like you see on the screen, that's like kind of the absolute image you should never use on a slide, but we purposely done it just to kind of illustrate really just how much of a jungle it is, kind of choosing the tools to use. So, and it is crazy, and there's so many different options and things. So really, we want to kind of provide some kind of curation really on what we think the best choices are.
Yep. So what we are not going to be talking about are some basic concepts and the internal architecture. We'll expect you to know more or less what a pod is, what a deployment is, and some basic things like that. Also, I wouldn't even know myself how to operate a Kubernetes cluster, so I'm not going to talk about it. I just usually try to use an actual real cluster rather than trying to operate one myself. So this is something we're going to be talking.
Yeah, and I think it's worth saying that there's some other great talks and videos online that if you do want the kind of 101 Kubernetes thing, it's definitely worth spending maybe an hour or something just to kind of learn what some of the concepts are. The big thing really is how things are named as well. So, what's a replica set? Because you're going to hear these kind of words and names of things. So yeah, that's kind of important, I think. So definitely worth. Yeah.
Totally. Yeah, so this is the slide where all the examples we're going to be coding now and more stuff we haven't had the time to do in just such a small slot. Everything is here, so just take a look at it. Just let us know if you have any feedback. Please open some issues and let us know what you think. But this is where you will find all the content that we're going to be talking about today. So you have to worry about the slides and everything. Just everything is here right now. Okay. Coding time. This is going to be all, actually. All the slides we have. So don't tell Josh, but I don't use Stardust Spring.io. I usually bootstrap my projects using IntelliJ. But there's also a Spring initializer over here. So I'm just going to do that. I'm going to start from scratch, right? I'm going to create a new app called My App, just to not to make it complicated. I'm going to use Gradle because I can and I like it. And I'm going to bring two dependencies, actuator, because that's going to bring some useful stuff that we're going to need later. And I'm going to bring web because we want to return hello world, right? This is a conference talk. And I'm going to use the latest milestone of Spring Boot 2.3 because it contains some optimizations. I don't know if you want to say.
Yeah, so from Spring Boot, I think definitely, I don't know how many of you are Spring developers, but so when Spring Boot was initially designed, it was sort of designed from the ground up to be a cloud-native platform, and it fits really well for building workloads on Kubernetes. So there's a few kind of really compelling reasons why that's true. So it works really well with the sort of features that Kubernetes provides you. So one of those features is Kubernetes will provide you configuration either via like environment variables or via a file on the file system. And Spring Boot will be able to actually automatically kind of marshal that data and present it to you as a kind of a Java object model. So when you're working on K8s, that's actually really, really useful. One of the other things is the support for actuators. So actuators, again, really handy when you're deploying your apps here because you can sort of configure. We'll show you later, but you can configure the cluster so it can use those actuators to actually kind of get status of your application, and also things like providing metrics with Prometheus, metrics and that kind of thing. I think in the future, the one to watch for me is GraalVM. So we're working really closely with the GraalVM sort of compiler team to make sure that having first-class support for GraalVM on boot. And what that means is much smaller images, so kind of comparable to what you get with something like Golang. So you kind of got this single kind of binary, and it's speed as well. So speed sort of run your containers. So for some people, that's a really big deal, and it's one of the reasons why sort of Go is so popular. So we really hope that kind of Java and Spring experience will become a lot closer to what you get with Go. So.
Okay, so let's just do this, right? So we are going to have a controller, right? Just going to say hello world. Nothing super special, really. I'm going to class a hello controller. And this is the class we're going to be iterating with, just to change something and see how this works. The map pin that's going to respond to hello. Again, nothing complicated, nothing super special, just to have something that we can visualize how this is going to be iterated, right? Swing, get hello, return hello world, world, okie doke. If I don't have any typo, which I do, obviously. Okay, cool. So this, I'm not gonna ask for an applause or anything. If we were in a Cloud Foundry talk, it will be just something like, hey, CF push my app, and we will be done, and going out, being happy. But because we are not there, we have to worry about more things. So right now we have an app, right? So now we need to put this app into K8s. What do we need to do? So today, the standard de facto way to put your application in Kubernetes is by using a Docker container. And there are many ways to do this. The Spring Boot is providing some support, like you can build your Docker files by hand. But it looks cool for the first day. But after a little bit, there are so many good practices that appear and so many things that can go wrong if you do that by hand that we will highly recommend you to use our tool. And to me, as of today, the best tool to do that is Git, which is a tool created by Google to containerize Java applications. It comes with a Gradle and Maven plugin. So I'm just going to use the Gradle plugin over here, if Wi-Fi allows me. Yeah. Okay. It's going to do this. It's going to add it to a Gradle file. Okay. And now, in IntelliJ, we should have two new tasks, or one task appearing. So we have now Jib, and you can see that well, but we're going to talk about them. So there are three new tasks that got imported. Let's use one of them. So one of the great things about Jib is that you don't need a Docker daemon to run, but you can. So let's just go to my app, and let's just build the image locally. So what this is going to do is going to just create an image for us, right? There are many ways, again, so you can just build the Docker hide by hand, but with Jib, it's going to apply all the good practices just for us, right? We're going to see what it creates. It creates already a very tiny image. There are many ways to make it smaller, but still, I don't think the image is the main thing you should be worried about, but the base image that's been used and how the layers are structured, right? So with the Docker images, locally, we have now this new image, and we can take a look at it, actually. History, the image. And we see how the layers are split, right? So this is important because in order to be productive locally, you don't want to re-upload the whole thing. So let's say we have a chunk, an image that is, the whole size, like 143 megs. If I just change my text from Hello World to Hello Atlanta, I don't want the whole 100 megabytes layer to be reapplied, right? If I only change one class, I only want this tiny layer to be the one that changes, right? It's only 1 kilobyte, what is going to be re-uploaded, right? So just by using the right tool or by splitting the right way, we will have all this productivity straight for us, right?
So the moral of the story is don't put your fat jar in a Docker container. We've all done it. Don't do it, basically.
Mm-hmm. Yes. A good summary. So now this is locally, but in order for this image to be used, downloaded by a cluster, I need to upload it somewhere. So I'm just going to use another git command to put it into my Docker registry. So I'm going to use the image. I'm going to call it Alberto, my app. And it's going to do the same thing, but instead of having into my local daemon, without using any local daemon, I could have killed Docker right now and still will be working, especially for CI, this is how we use it. And this is going to upload the image now into Docker Hub, right? So if Wi-Fi allows, which it did, only 11 seconds, and we go now to Docker Hub, we should see that the image was uploaded seconds ago. Yeah, so a few seconds ago, now we have that. So we have an app, we have an image, and we need a cluster. So what are we going to use? A local development cluster. I'm a big fan of Kind. It stands for Kubernetes in Docker, and it creates local cluster to test Docker locally. The good thing about this tool, it works in all the major operating systems. You have Windows user, Mac OS, Linux. This works, and the key feature to me that you can create and destroy a cluster in just 20 seconds. In my machine, it took like 40, probably because I had a Slack open at that moment. But just 20 seconds what it creates. This is perfect for CI. So this project I'm going to be working on, I'm really going to use this because I can just create a cluster, run on my test, and trash it afterwards, right? So for my local machine, I just have it here, and it has almost all the features that you will need, apart from networking, which is something that's not that trivial to implement locally. But most of the things are there, and it's just very easy. There are other alternatives, but this is the one we're going to be using today. And this is already here now. Okay, so now let's talk about the next thing, right? So I guess this is the elephant in the room when it comes to how to put that. So we have the local cluster, but now let's talk about the real thing. So YAML. There are many ways to create a deployment and to put it into Kubernetes, but I haven't found the best way yet. There are some tools like, like Decorate that it's great for like Hello World examples because you just add a dependency to your Java application that you have the manifest being generated for you. But the second day, when you want to modify some things, you have to kind of guess how to use the tool to generate the YAML you would expect. So it's great for day one, but for day two, I didn't find it super useful yet. And there are a few ways.
It's great actually for Decorate as well, worth looking at for educational reasons because it will generate a sensible kind of starting point YAML. So I found that quite helpful.
Yeah, and the community is great. Like we have submitted some pull requests and they're super responsive and it's looking really well. Just for the day two, I haven't found it still be my choice of preference. So I'm going to create a new directory where I'm going to start creating all my YAMLs. So I'm going to do deployment.yaml. And for example, IntelliJ, so by the way, haven't said that, but I'm using a plugin called Cloud Code, and it just contains so many utilities when you're using IntelliJ or VS Studio that you can do everything we're going to do without this and without any of these two IDEs if you prefer another one. But I like IntelliJ, and this is what I use typically on my daily.
This is a Google tool, isn't it? I think.
Yeah, it's developed by Google Cloud team. Cool. So one of the first ways that we have to generate or to start creating our deployment is by using this. So I can just say, hey, Kubernetes deployment, and boom, you have already.
That's not so bad.
No, it's not super painful, compared to having to learn more tools, just type in two things and I can just say my app. But honestly, I still don't, this is not how I create it. I personally come back to the CLI and I do this create command. So you can create objects in K8s by using the CLI. So here I'm just doing a basic create deployment command. And I'm just naming it, called my app because it's our app name, and I'm passing the image that we have uploaded before into Docker Hub. And I'm using these two commands, right? So this is dry run, and this is what we're gonna do is validation. So I use this command only for this bootstrapping phase, but also when I modify some file just to see if this is working. It's gonna do some client-side validation. The newest version contains a dry run in the server side, or right?
So actually, I think we saw earlier, we tried to run this command without having a cluster started, and it failed. So it does depend on a cluster being there. Something we didn't mention, we should. So K is not a real command; it's just an alias for kubectl. So that's what it is, in case you're wondering.
Yep, thanks. And so I'm going to concatenate this dry run, which is going to validate, and is not going to apply it with changing the output to YAML. So what this is going to do is just outputting, just not applying it, and also making the output being YAML. And I'm just going to put that into the deployment file we created before. And what this is going to do, is going to do the same thing that we generated with IntelliJ, but now we have all the defaults, my app, all the labels you would expect, the image being picked up that we specified. And this is a good starting point, actually. So let's apply this. It's going to apply like that. Okay, so we should have now a pod coming up. And do you see this ready? So this ready is something that I get wrong all the time, and it caused me several issues in the past. And Case provides a way for us to really tell him how our application is behaving, and if you should be restarting it, or you should be sending traffic to it. So we are going to be using something called probes. Do you want to?
Yeah, so to explain what probes are, they're really quite straightforward. So there's two types of probe. There's a liveness probe and there's a readiness probe. So I'll start with the readiness probe, and that really just is an indication to Kubernetes has a control plane, and it's kind of monitoring like the health of the various pieces of workload. So it checks to see that your pod is ready to receive, so it's live, it's started, it's ready to start receiving traffic. That is the readiness probe. I always get this wrong. The liveness probe is the thing that kind of is continuously monitored, and if the liveness the liveness check fails, then that sort of will get the pods will get restarted. So it's Kubernetes' way of just keeping the house tidy.
Yeah, so basically they respond to the question. So the liveness will respond to the question, should I be restarted? And I would say the best way as of today to do this is setting a track to info. Because that means, hey, my application started, I can, I'm alive, please do not restart me. But that doesn't mean that all my external dependencies are okay. For that, we have the readiness probe where we are going to say actuator health, right? So that means if the problem with doing this, which is what I used to do in the past, is that if you have a problem with an external dependency, let's say you are consuming an external services, you implement a health check for that. Whenever you, if this fail, if the other upstream service is down for some reason, okay, it's going to come and restart all your pods, and it's going to cause, okay, I'm going to send again. Okay, should I restart you again? Yes, so it's going to create a cascade all upwards, right? So this is why you should say, okay, do not restart me because I'm still setting myself up. I'm going to do actuator info and then actuator health, right? So with that said, let's delete this. Oh yeah, do you want to?
So yeah, one other thing I just wanted to mention really, kind of while we're on the subject of how to kind of build your manifest. So we've kind of shown the two ways, but there's a third way I really wanted to actually talk about today, but just because we've only got an hour, I just didn't have time. And there's a tool called JSONnet. This is another thing that, again, was developed at Google. So instead of writing YAML, you're kind of writing a cross between JavaScript and Python. So some of my colleagues, I've shown it to Alberto, for example. I've really tried hard to convince him that this is a good thing to do and he won't have any of it. I've tried with one of my other colleagues, also will not have it. But I really love it because it's data, right? You're just dealing with the data. You're not dealing with text. And it's a data templating language, and it will let you kind of build a data model and then generate from that data model different output formats, JSON, YAML. Have you got that other link that I saved in the GitHub? So this is an example of so your Kubernetes manifest using JSON, it could just look like that, basically. So it's like a very, very reusable kind of way of defining your configuration. And it goes way beyond just Kubernetes. It will let you do Terraform, any kind of other configuration. So, but I would need an hour to go into depth for this, or maybe if I can get another proposal up and together, I'll do a talk on JSON next time. So, yeah, anyway.
Let's continue. So, we just destroyed everything. We just created our thingy, our deployment with the probes. Let's see if I didn't mess it up, as usual. Deployment. Okay, let's see if we don't have any restart yet, so it should be good. Okay. No, it doesn't seem to be ready. No. What did I do? It's okay. So right now, let's see. So we have a deployment where we need to, because we are in local environment, we need to create a service to actually expose our deployment, right? So I'm gonna just actually have this here. I'm gonna expose this. The same way I generated that, I generated the deployment, I can use the same for the service. So you can use the kubectl expose command, and you can pass the deployment file, or you could pass the name of the deployment you are using, right? Then we're gonna target to the pod 8080, and we are gonna use the same two commands that I run for validation, and the output being YAML. So it's gonna create another service. I'm gonna apply that. Apply F service, and we should have that now. Cool. Okay, so we have now a service. So let's see if this is working, by the way, because I haven't been here for a while. I haven't really run anything. What do we have to do? So because in our local machine, I need to port forward this into the ports that we want. And then now that I have port forwarded this, I can say curl localhost 8080 hello. Okay, so we are here. Now let's say, also, by the way, the logs. So you can tell the logs, but I usually use a tool called Stern, because by default, imagine you have 20 pods. You don't want to be tailing the 20 of them. I just want to use this tool because it just tails all of them. And it also color codes them, so it's very easy to see and to read whenever you have something spinning up and down. You just see these color codes, and this just keeps tailing over here. So let's say that we don't want to say hello world anymore. We want to say hello Atlanta, right? Let's say hello world Atlanta. What do we have to do? We have to do a lot of stuff again, right? We have to come back. We have to go and say, hey, Jib. Jib, I want to repush my image again. I have to wait for it to be uploaded, even though it's a tiny layer, because we are using Jib to optimize that for us. It's still some seconds that we have to waste. And if the Wi-Fi allows, we should have the image again in Docker Hub when that layer is pushed. And what else? We need to now tell, okay, so we have a pod, but we have to tell him, hey, please download the new image, right? Because he doesn't know that we have a new version being pushed. So I need to do a rollout restart. I'm going to just do that.
So why can't I just do the apply command again?
Because we need you to change the object metadata in order for it to know that you have to re-download something. Right? Or some people do like some tricky, like change an annotation and change it back. But I just usually do a rollout restart because in theory I'm re-uploading a new version, so I should go through my same flow, right? So I would just do a rollout restart, and that should now spin up a new thing. So you see how one of the pods is going down, and another just came up. And now if I want to call it, I have to do again a port forward. Right? So I have to go here. If I don't have any typo, port forward, 8080, 8080, and then we see how the new application came up and the other went down, by the colors. And finally, I'm going to crawl again. Oops, crawl host 8080, hello. And we have hello Atlanta. This was painful, really. But there are so many things that can go wrong. Because we're using G for tagging, but usually you will have a different tagging strategy that is not yet using this, the version of your artifact, right? Docker images. So many things can go wrong. You can mess it up with tagging. You can mess it up by restarting the wrong deployment or the wrong pod. The network can be flaky whatsoever. We just don't want to waste a minute, and we don't want to make that many mistakes. And there's a tool that's going to help us a lot into improving this workflow. It's called Scaffold. So in order to bait my Google, I'm just going to show really what it does and how to configure it rather than explaining more or less what it does, because we're going to see very quickly. So IntelliJ comes with an add-on that you can generate everything with the CLI. You don't need this, but I would rather just use saying add Kubernetes support. Okay, and this is going to generate a new file for us called scaffold.yaml. And it already knew, IntelliJ already knew that I'm using this image name. It knew that I'm using gib, and it knows the manifest that I created and how to deploy them. So just by doing this, it already does a lot of the stuff. So let's clean everything up. I'm going to delete my deployment and my service because this tool is going to help me to bootstrap that as well.
This is another tool from Google, isn't it?
Mm-hmm. Yeah, the kids of Kates, they kind of know how to do tools as well. Okay, so you see that this new thing up here, develop on Kubernetes. I'm just going to click run. Again, this is just doing under the hood. It's a scaffold that command. There's nothing special about it, but because I'm an IntelliJ, I'm just going to use that. And this tool is going to do a couple of things, right? So first of all, it's going to tag over image in a different way. So do you want to talk about the tagging, actually?
Yeah, so I think by default, what you see with Scaffold, when you look at the tag that it uses, it's actually just using like the SHA there, like SHA 256. So it's kind of okay, but I would not just use that default. So what I would usually do is actually make the image more semantic. So I would use the version number as part of your tag, and then I would probably use either something like the SHA or just maybe like a build number from something. So for me, that tag, I wouldn't be able to kind of do Docker images. And I want to see some more contextual information there. So for me, that is not hugely useful, seeing that big commit SHA. So, and in Scaffold, you can configure that to make sure that you can give it a strategy to use a more sensible image name. And this is really, if you're actually wanting to publish your Docker image for wider consumption by the community, it's even more important to use sensible tagging. So you really do need to think about that, I think.
Yep, so that's it. So it's going to create a new tag. It's going to actually create our deployment and our service for us. And it is also going to do the port forwarding, right? And also the logs. So you see all the things we did before that we can now get rid of a lot of them. So we don't need almost any of the things we have here. We just now can do hello world and there's the new port, hello Atlanta. And now the good thing about this tool is that I don't need to do again hello Atlanta. I can say hello Devnexus. If I don't do the typo here. And this is going to automatically detect that we're changing things, and it's going to create a new tag, and it's going to recreate everything, and it's going to do everything for us, right? So right now, instead of us doing everything, it's just one tool that's handling all that workflow for us. And the great thing is that this tool integrates very well with so many ones that we're going to see a few more later. But why I think Scaffold is my main backbone of all my workflow is because it can be integrated with so many tools that I just use it for all the time. So you see, the new things came up. We have the logs again. So now we should be able to say hello. Oops, come on, don't fail me. Don't fail me live. Okay, yeah. So it should be another port. Okay, Hello, Devnexus. Okay, so this is something now, right? But this is a much an improvement to what we have. There's little room for failure, but this is not it, right? So normally, your life is not this easy, right? That you don't have just a simple deployment with this thing, even though we already, we just started and we already had to add some props to it. But the reality is that you will have to add many other configurations, particularly if you are, I don't know, like in the different environments, we have different needs, and different environments will contain different tools, like monitoring tools, for example. That's the most use case, the most common one. You maybe have Prometheus point in one place and not in the other.
So you mean like sort of a development cluster, production cluster,
Exactly.
will have a different version of maybe the database settings will be different, or more security in one of them, or that sort of thing?
For example, and one thing also that it does, actually, when you stop it, it also deletes everything, so it cleans up himself. Actually, we can show how this works, by the way. Do you want to talk about the labels?
Yeah, sure. So one of the things I think we saw, did you bring up the labels? So what Scaffold actually does behind the scenes, the resources that it creates, it will actually create labels for them. The labels are really, really important. So what they'll do, it will give you, it's what Scaffold actually uses to know, all right, I manage this, it's part of this kind of deployment, this is the timestamp, and this kind of thing. But as developers, we should also be thinking about labels when we do deployment. So a real typical example for me, and if you think about sort of domain-driven design, you have a kind of an aggregate of microservices. That would be a really useful label to make sure you have. So let's say your app's called shopping cart, and that's like an aggregate of 3 different microservices. So your label might be aggregate shopping cart, and then you can do things like, okay, well, I want to see really easily a query in one command, show me all everything, every resource related to shopping cart. So then you can do things like maybe we want to restart everything just in that set of microservices. So definitely a strategy to be thinking about, as well as tags. So.
Cool. Yeah, thanks, man. So apart from that, so we say this is how Scaffold uses tags also to know what to delete, because it groups them by the label. So when you stop it, everything gets deleted, right? So we again have a clear cluster because it cleans up himself. But reality, as we were saying, is that you're not going to have such a simple deployments, that you want to add things on top and remove things depending on the environment you're working on. For that, we're going to be using a tool called Customize, which is one of my favorite tools right now, to be honest, on this space, because it helps you attach, and it allows you to have your deployments and all your manifests untouched, and you can apply things on top without using any templated language, which is usually a nightmare to me.
So it's almost like, I suppose, having like a partial, I'd call it, like a partial reusable kind of bit of YAML, isn't it? Exactly. That you can kind of join them like kind of a Lego bricks, I suppose, and then you've got a bigger bit of YAML at the end.
Let's see how this works. So so we're going to go to our file there, right? We have this deployment and server.yaml, and for that, we're going to have to get a new file called customization, if I don't have any typo, customization.yaml, and we're going to use a tool called Customize, so we said, and we are going to add that. So we're going to add a resource called the service, and we are going to add also our deployment. And then we just see what we just created. We have a new customization created over here. Okay, so we could be using now Customize. Also, Customize can be integrated with the latest version of the kubectl CLI, but I never use that. So I could be doing this, like, okay, apply -K instead of F to build my files. But I prefer not to, because this version is not a plugin. This is actually embedded in the CLI. And the second you want to try something new, or you have a new version in your manifest, it's not going to match what you have in the kubectl. So I never use that, to be honest. I will go customize, build that, right? This is what I would do. Right now, this is not doing anything, right? This is just concatenating the 2 files that we have, because we didn't apply any customization on top of the 2 ones we have had, right? So let me delete what I just created by accident. Delete. Okay, so I have anything now? Good. And so what we are going to do now, we're going to say this is going to be our base. So I'm just going to go and create a base folder, and I'm just going to move my deployment to that base, and I'm going to move my customization to that base.
So the base is the things that will be common across all of our, every time we run customize, right? That's the common part that we'll get. be used.
Exactly. So this is the things that we don't want to touch, regardless of the environment we're in. This is the this is the constant things we're going to be having, right? So on top of this, we want to start applying overlays, which is the code feature that's going to help us adding more things on top, like environment variables, applying different config maps, or like scaling in and out. So this is what we're going to be creating now. So I'm going to create a folder called overlays, and I'm going to create an overlay for development and another one for production. And right now, I don't have a good way to really do this, to just generate all those files by hand, because it's kind of funny to see people doing that, but just shamelessly copy the whole YAML file. Because it's 2020, I don't generate YAMLs, just copy paste them, right? So I'm just gonna see it. We're gonna show now. So this is the actual structure how this should look like. So we have two new customization files. Let's look at them now. So we have an overlay for development, and we are just saying, I want to apply these two patches called replicas and profiles, and I want to prefix everything with development. And then we take a look at the production one. It's an equivalent, but just without the prefix, right? So what are the profiles look like? So profiles, for example, in dev, it's very common to say, I want to apply a development profile. So we just say, I want to create a new environment called Spring Profiles Active Development, and the equivalent for production, right? So we do div, both files. For development, we're going to be dev. For production, it's going to be production. And this without touching the actual deployment of YAML, right? This is the sweet spot. Also, for replicas, for example, we could have 1 replica in dev and 5 in production. So how do you use this thing? So again, we can just say build, and I want to build my overlays in production. And if I do this, I see, oops, I customize. Where am I?
In the wrong.
No, where? Wait a second. I forgot the command. It's customize, build, overlays, production. Okay, I don't know what the pipe. Anyway, so now by just building that, we have an environment variable called production. We have our pros that we specified before. We have 5 replicas, and we should be able to create this. But we were saying, this is a great tool, but I want all my tools to be integrated, right? So I want to play this with Scaffold, right? I don't want to do this by hand again and being again on this workflow of having to manually apply things. So let's use Scaffold now for that. We are going to go to our scaffold.yaml. And before we're saying I want to do this, deploy this using kubectl, now I don't want this. Now what I want is to use customize. You could be using Helm or some different strategies, but we're going to be using customize right now. So our base path is going to be what we have here. This is going to be the default. So by default, we're going to just deploy what we have on base. But also, it comes with a feature called profiles. So we have profiles, and I'm going to create a profile for development. And this is going to we want to deploy this again by using customize, and the path is going to be Kates, overlays, development, and we want to create a new profile again, but for production, right? So I'm just going to do this. Production, okay. And because of IntelliJ, it also knows that we have now these profiles created over here. We can use a production profile, for example, and we can apply that. Let's do this, and I'm going to click run. And we should be seeing now how, sure. Yeah, I'm so used to use the alias. Cool. We see now how 5 pods just were created right now, right? This is all within our development environment, in our IDE, using our tools, everything here, right? Again, you don't need IntelliJ. You can just do a scaffold dev and the same behavior, whatever you are, or just like IntelliJ, and this is what I'm using right now. But we see how the new pods are coming up, and so on. Yeah, this is pretty much.
Yeah, so I think I just wanted to mention a couple of other features around Customize that I've found really useful. So one of those is that you can actually point at a GitHub URL for those overlays. And what that's really great for if you want to share either within your organization or perhaps even to a wider party, your kind of customizations, right? So maybe you've got a very specific configuration for, say, Prometheus, and you want every team in your organization to use that same customization. You can point it directly to a GitHub URI, which I think is really quite powerful technique. And that's certainly something we on the Spring team are looking at as a way of kind of providing quite a set of curated, sensible defaults. So definitely worth exploring. And the other thing Customize does quite well is generating stuff. So in particular, you can ask it to generate config maps. So you can have the same kind of pattern, right? And then you can kind of say, okay, well, given this data, also give me a configuration map. So that's another feature that's really good.
Yeah, and also there's another tool that I use often, apart from that. It's called Octant. That I you just need to install it locally. You don't need to install anything in your cluster. As you saw before, my cluster was just brand new, was just generated. So this tool, you install it locally. And whatever you have access to see, this tool is going to show it to you, but in a graphic way. Like sometimes I don't feel like typing commands. As you saw today, wasn't one of my typing days. But you can see everything graphically over here. And everything you have access to see, you will see, and no more. And the good thing about that, there's no security implication, right? Because you need to install anything in your cluster. If you can see it by using commands, you can just see it by using this tool. Some cool thing that it does, you can see the resources graphically. It's over here. This color is about the status of the pod or the service or whatever you have over here. You can see the logs. You can see the actual YAML representation of the object. And for example, you can see like config map values. You can see like the secrets that are created over here. You can see everything you have access to see. You will be able to see it in a graphical way. The tool is called Octant. Let's see how. Octant. It's on GitHub. And it's also, I believe it works in all the major operating systems because it's such an easy tool to install. GitHub, Octant, come on. There you go. Yeah, Octant. There we go.
So there's one more thing, isn't there? So something I think is really something we often need to do is, okay, where's the database? Where's the message queue or something? So the tool generally that we're going to use for that is something called Helm. So for most people, they have really quite a bit of a love-hate relationship really with Helm. So if you think, the way I think about Helm is that it's the kind of like apt-get for Kubernetes, right? So if I just open up,
2 minutes ago.
Yeah. So I can sort of show you what the charts. You've got this thing called a chart in Helm, and let's just pick, let's say, let's pick Artifactory. So let's say I want a Artifactory server deployed on my Kubernetes. So this Helm tool, it references these charts, which are stored in GitHub. So you have this chart, and this is really can be these things. There's probably not. I can find a better example actually, because this one is quite. Let's find another one. Console. So you basically, it's this is templating YAML. So and this is you can see this is a really big one. That's what I was looking for. So you can see. I mean, hands up who thinks this looks nice. I mean, wow. Gosh, I mean, it's really quite hard to understand. But the thing is, the good thing about it is that all these charts are generally curated by the actual kind of service owners. So HashiCorp in this case probably maintain the Helm chart. So the good thing about it is that you can kind of ensure you're kind of getting a kind of sensible set of kind of configuration. But the onus generally is on the kind of user, the developer, to actually make sure that you kind of set the right variables. If you go back to console here, you can see in the README, usually it tells you all these parameters here. So all the things that you can kind of configure, you can kind of provide in this like values file. So actually go and let's kind of run through one of these. I was going to do the database server. So have to excuse me, I'm going to be a bit slower because this isn't my laptop. So okay, let's make sure it's big enough. So where are we? We're in the right folder. So what I'm going to do. So we've got the Helm command. So originally, this is Helm version 3 we're using now, and originally Helm required you to install something on your Kubernetes cluster called Tiller. Now you don't have to do that, so it's great. So it's purely like a client-side tool. So let's do another command. So we can do, So first thing you do, you add in this like the repository. So usually you're going to be using stable as your repository. But what you could do, many people probably do, internally you can manage your own kind of set of charts. So you might point that at your own kind of location. Take a little while to add that. Yeah, that's done. Brilliant. So now this hopefully this helm list command will now helm search, isn't it? Yeah, okay. Yeah, so I have the command log. So you can see here, it will give you a nice list of all the different sort of charts that are available to you, same as that GitHub repo. So what I was going to do, so what you can do with Helm is you can just do Helm install. So I'm not going to do that, and there's a good reason why. Is because if we go back to look at our scaffold.yaml, you can see here, so at the moment, scaffold only actually supports one method of deployment. So what I'm going to do instead, I'm going to go to Helm and basically ask Helm to just give me all that YAML, but fill in or populate all the values. So you just get another Kubernetes manifest. I genuinely just prefer this method because it means then you can keep the actual, what's the word to say, it's like you snapshotted the kind of, that version of the Helm chart. It's in source control. There's less mystery about it, in my opinion, and you can integrate it much easier with other tools. So let's go ahead and do that. Helm template. So I'm going to, what I'm going to do here, so Helm template, MyAppDB, that's like the name that we want to use for the when we actually populate that file, and we're going to use a stable PostgreSQL, and we're going to put it out to this YAML file here. Okay, so we now should be able to have a look at the file. So you can see now it's actually given us quite a big amount of YAML there. So this is why Helm's super useful, because it's just it saves you from, especially with databases and things, there's so many things that you have to think about. So it's like created a stateful set, some services, and any of these values that you're not happy with, maybe passwords, usernames, stuff like that, then you can very easily just edit the template, the value, provide it with a different value. There's a minus values flag with Helm. So I think I'm actually going to have to move that file into the customization folder. I think it's base. Yeah. And then I think I can do that same edit command that Alberto used. So customize. So edit. So we're going to add now Postgres resource into the customization.
And the benefit of doing it that way is that you can have all your helm chart that could live in a different line cycle by running different commands. You can integrate all of them with this. This is a good point. I think Scaffold, I don't know if it does it yet actually, but it still do not support more than one way at the same time of deploying things. This is why this is one workaround that you could find there for you to have your whole temp charts as well as part of your workflow. But you have to do this export right now, but in the future we hope that this experience could be better. But this is what we are doing now.
Oh, it's good. Yeah. Okay. I did that wrong, didn't I? Do I have to do?
Wasn't looking great. Yes. No, you have to be inside the base and add it from the base.
Yeah, I got you. Yeah. Okay, so now we should be able to look again at the customization. Yeah, so I mean, it would probably, I could have easily just edited, done that myself, but yeah, fine. So now we should just be able to, I'm going to use the command line way of doing it. So you can say, instead of using IntelliJ, you can just write in scaffold dev. And I've done it in the wrong folder. Oh, is it still, it's running in another place?
Probably, yeah. Click from IntelliJ, it should be okay.
Yeah, okay.
Yeah, kill it. On the top right. Yeah, so again, the good point about doing it is this way is that you can have all your tools and all your services in the same folder and in the same customization and modify them in the same way, right? So it's just one way to do the whole things. And if we go now to the CLI, you can see how everything was created again without leaving our scaffold and without using the same tools that we were using before.
So you see at the top on that screen, we've got our PostgreSQL container creating. It's a really good way of getting your dependent services, databases, message queues. So.
Yeah, I think this is all right.
So I think we're probably about wrapping up now, aren't we?
Yeah, I think so. I think this is the time we got. So thank you very much. You have any questions? We have some time, otherwise we're going to be around anyway. So
yeah, come and talk to us, or talk to us on GitHub, anything like that, if you want to ask questions. So.
Thank you.